Hello everyone. In this video, I'm going to be talking about linear inequality in two variable. We will be learning how to solve linear inequality in two variable by graphing, and that is the only way to solve such inequality. We're going to start it by do a quick recall on linear equation in two variable. As you already know, linear equation in two variable is in the form ax plus by equals c, right? Now, if you replace the equal sign with one of the inequality symbol, then it becomes linear inequality in two variable. All right, so let's get started. All right, section. 2.4 linear inequality in two variable. Alright. So linear equation in two variable, as you know, is in the form ax plus by equals c, right? And we know that linear inequality symbol is inequality symbol will be something like this: greater than, less than, greater than, equal, less than, equal. So I'm gonna just go ahead and replace the equal sign here with one of this, then it become linear inequality into variable. That's simple. Okay, and as you know, every time we show inequality, the solution is not just one or two, it's infinitely many solutions. And so is linear inequality. The solution contain many solutions, infinitely many solutions. And there are two methods of solving linear inequality in two variables. I'm going to introduce to you right now. But first of all, let me give you a couple of examples of a linear inequality in two variables look like. I can have something like this: 2x plus 5y less than 10, for example. Or I can have something like negative 4x plus 1 over 2y greater than equal negative 7, for example. Okay, so I just use one of the inequality symbol, then it become linear inequality in two variable. Very simple that way. All right, now, so that is the definition. Now we're gonna learn. We're gonna jump on how to solve linear inequality in two variable. How we're gonna do that? So on the second part, let me see. What color should I use right now? I think I'm gonna use this one. Method of showing linear inequality in two variable. Alright, and there are two methods. Most of the time I'm going to use the second one, but let me introduce the first one first. First method, method 1. In this method, we're gonna pick a point. Okay, if we pick a point and we replace x and y with the with the components of that point, and it satisfies the inequality, then we're gonna set the area that contain that point. Okay, so method 1, I'm gonna call it picking point. Alright, how many points you want to pick? Usually you can pick only one point, it should be enough. You can pick 2 points if you want to make sure. So picking 1 point is good enough. Alright, Let's start with our equation like this. Not equation, I'm sorry. Let's start with our inequality like this. Example 1. I have x plus 5. How about this? Let's do a 3x plus 2y greater than equal 6. Okay. So in order to solve this, first of all, this is a standard form, right? Ax plus by equal to, so this is this is standard form. Excuse me. So we have to convert a standard form to slope-intercept form. Slope-intercept form we already learned in section 2.3. So we're gonna convert it to slope-intercept form. That's the first step you should do. So in order to convert to slope-intercept form, you're gonna subtract both sides by 3x. Okay. Then you divide both sides by 2. 6 divided by 2 give you 3. Alright, so over here we have, you see that? This is the slope right here. Okay, the reason we want to convert to slope-intercept form because you want to graph it. Okay, you want to graph it. If you cannot graph, then you cannot solve the linear equality in two variables. So over here, I think I'm gonna add a little bit here. So actually, this is graphing. Even no matter what you use, method 1 or method 2, you have to graph it. Alright, so let's graph it. Let me graph. I'm going to use rise over run method to graph this. Okay, this is your x, this is your y. Excuse me. Again, you're going to start with the y-intercept value. So this 1, 2, so the 3 right here. So we're going to start over here. And we go down 3 units, right? Because negative 3 means you go down. And you go to the right 2 units. So going down 1, 2, 3. Going to the right 1, 2. There you go. So 2, 3 here. So now I have the line. Okay, I have the line. Let me see. I can draw the straight line. Kind of hard to draw the straight line over here. There you go. There you go. Let me use the different color here. So I have this point right here and a point right here. Alright, 3 and 2. And the reason that I use the solid line because it is equal. If it doesn't have the equal sign right here, then I have to use the dash line. Okay, so after you draw the line, you see that this line over here is divide the coordinate system into 2 halves, right? You see the part right over here and the part under the line. It's the part above the line and the part under the line. So we're gonna pick a point. Okay, we're gonna pick a point. So let's see the part over here or the part down here will be the solution of the inequality. So either here or here. So I'm gonna pick a point. Make sure that you're gonna pick the point inside inside this area. Okay. I think I'm gonna pick 3 and 4. Let's pick 3 and 4. Let's see what happened. So here 4 here. So let's pick a point right over here. Okay. 3 and 4. Okay. Okay. All right. So 3 and 4. Let's see if this point over here satisfy the inequality or not. Okay. So I'm gonna plug it in. Okay, excuse me. I'm gonna plug it in. So I'm gonna put 3, right? X is also 3. All right, x is also 3. Plus 2, right? Y is what? Y is 4. Alright, let's calculate it and see if it is greater than equal to 6. If it is greater than equal to 6, then it should be the solution, the area here. Yes, it is, right? 23 times 9 plus 8 is, of course, is always greater than 6. So this is true. This is true. So it means what? It means this is the solution. So, and because this area here is the solution, so I'm gonna go ahead and shade it. Alright, so I'm gonna go ahead and shade it. Alright, there you go. Alright, there you go. So that will be the solution of inequality. So let me extend this a little bit. There you go. I just want to make it more beautiful. Alright, here you go. So that will be your answer. Okay. Now, we can also use the second method for this problem too. So I'm gonna start with the second method. Method 2. On method 2, you just need to look at a graph, okay, and applies the fact that if it is greater than, okay, or greater than equal, then you're gonna shading above the line. Alright, if it is less than or less than equal, then we're gonna shade it below the line. Alright, you see that because this is greater than equal, so I'm gonna shade everything above the line. Alright, this is below, this is above, this is below. Okay, alright. Now let's do the problem here. How about we pick something interesting. 2x plus 2x plus 5y less than 10. No, less than 10. Alright, so I'm going to use the second method to do this, but either what method you use, you have to convert to slope-intercept form. So go ahead, convert it to slope-intercept form, and divide both sides by 5. So you have -2 over x, 10 divided by 5 is 2. Alright, and you see that this is not it doesn't have equal sign, so you have to use the dashed line instead of the solid line as last time. Okay. Alright. Okay. So this is your x, this is y. Alright, so we're gonna start at 2. Okay, we'll start at 2, and then you start right over here. This 1. And you go to down 2 units and go into the right 5 units. So go into the right 1, 2, 3, 4, 5. Alright, and this is 2. Alright, and you just go ahead draw the dash line. Let me try to draw the dash line over here. It's kind of hard to draw it because I don't have the ruler. Let's see, I can have the ruler here. Let's see. Excuse me. So let me see. Let me see. Yeah, it's still hard. It's very hard because I cannot see the. So I just take a guess right here. Something like this. Okay. So I have a dash line. There you go. I have a dashed line. It's not really a straight line, you know, but I'm trying to. All right. Anyway, because this is less than, right? So and because it's less than, so less than mean below the line. So I'm gonna set everything below the line. Okay, everything below the line. So this is below, this is above. All right, everything below that. There you go. All right. Okay. Okay. All right. Below. So actually, I really prefer the second method. You know, the first method is good too, but you have to plug it in check. You know, so sometimes it takes a lot of time. Now, let me give you a kind of very special linear inequality and see how you're gonna graph it. Okay. What if I have something like this? What if I want you to graph this? X greater than 2 for a second. Okay. So again, well, this is you don't have to convert to slope-intercept form anymore because it's already in a very simple form already. So you just go ahead and graph it. Okay. So x equal 2. X equal 2 is the vertical line. So this one up here, 2 over here, and because it's equal, right? So it's equal. So I'm gonna draw the vertical line, the solid line. There you go. All right. And excuse me. And because of it's just greater than, it's greater than, right? So if it's greater than, so it should be on the right hand side. Okay. For example, you pick a 5, right? 5. 1, 2, 3, 2, 3, 4, 5, right? 5 greater than 2, so to satisfy that. So I'm gonna just pick this one. Okay. So let me use this color here. There you go. Alright, so this kind of a very special case. How about I have something like this? Oh, back to white color. What if I have something like this? Y less than -1. Alright, for this, kind of the same thing. Just go ahead and draw the coordinate system. Draw the line y equal to -1. So this -1 right here, right? And because this is the it doesn't have an equal sign, so we have to use the dash line. Okay. Okay. So that's the dash. And because it's less than, so you're gonna set everything below that. Okay. Here you go. All right. That's it. That's simple. nothing really hard here. And you can solve the system too. You know, sometimes they want you to solve the system. Sometimes they ask you to solve like two compound linear inequality into a variable. Okay. For example, in this case, I can give you another example. Okay. Example. What if I want you to get the solution for this compound? X plus y less than x, let's see which one, x plus y less than or equal to 1 and x greater than 1. Okay. We already learned the compound inequality, I believe so. Yeah, in section 1.5. Okay, I believe that we already learned compound inequality. Well, let me check one more time. Let me see. Last time we learned how to solve linear inequality in one variable, right? Have we learned compound inequality yet? No, you have not learned compound inequality. You have not learned compound inequality. However, this time they give you the compound. Compound means the combination, um, and we can solve this by graphing too. Okay. So this is compound inequality. So all right. So this it's kind of new, compound inequality, and we're gonna solve this algebraically or graphically. In this section, they talk about graphical methods. So I'm gonna solve this by graphing. Okay, by graphing. Okay. All right. So let's graph it. Okay. So first of all, this is not in the slope-intercept form. So I'll go ahead and convert it to slope-intercept form. I subtract both sides by x. Okay. And it's greater than 1. This I just rewrite it. Now I'm gonna graph it. You can solve compound inequality manually too. I mean algebraically, but in this course, we don't want we don't need to solve. We don't need learning that method. I mean solving algebraically. We just need to solve graphically. Okay. All right. X Y. So let's graph the first one first. So this is start. I'm going to use rise over run method. So we will here, you go down 1 unit, go into the right 1 unit. So I assume that everybody already know how to graph this. Last time I already showed you using the rise over run method. And we're gonna get a line. Oops. Wow, it's not nice at all. I mean, it's kind of hard to draw the line right here. Okay, so I'm gonna go like this. Very hard, guys. Okay, there you go. All right. So this is this one. Okay, this is one right here, one right here. Okay, then this is equal sign, so we're gonna use the solid line, and this is less than. So it's gonna be, we're gonna shed everything under the line. So I'm gonna shed it in red color. So I'm gonna shed everything under the line because it's less than, right? Okay. All right. Now let's do the second one. So we already finished the first one. For x greater than 1, so 1 right here, greater than, so it's very easy. It's going to be a vertical line, right? And it should be the solid line too because it's equal sign. So I'm going to just go ahead and draw the solid line, the vertical line. There you go. And this is greater than. This is greater than, then should be, let me extend this. There should be on the right hand side, okay? Should be on the right hand side, so I'm going to set everything on the right hand side. Alright, alright, okay. Alright, then what is the solution? If you notice, um, uh, if you notice over here, there's the red part and the blue part over here is kind of overlapping, right? It's kind of overlapping. So in this area right here, it's overlapping this area over here. And it means what? And it means intersection. So I just want to remind over here. So and it means intersection. That's what it means. And so intersection, it means you want to find the part is overlapping each other. So the solution will be everything in here. So I'm gonna use another color to shade the final solution. I'm gonna use red. Okay. So whatever you see red and blue overlapping each other, that will be the solution. So the solution will be this. Here you go. Okay, be that. Okay. All right. So that is for N. What if I want to do all? Let's do all. Alright, let's do all. Okay. Next example. We gotta do all, okay? All it means union. Okay, all mean union. Oops. Example. Okay. How about this? X minus y greater than equal to 1, and or x plus y greater than equal to 4. So all mean a union, and union means you take everything. Okay, union means taking everything. Intersection, I mean you take the shared part only, the one is overlapping each other. Alright, solution. Again, you see that it's not in the slope-intercept form, so go ahead and convert it to slope-intercept form. Alright, minus 2 plus 1. You go ahead and divide by -1, you're gonna flip the direction of the inequality, so it's going to be greater than equal to x minus 1. Alright, or x plus y less than equal to 4, so y less than equal to x plus 4. There you go. So it in slope intercept form already. And it's in slope intercept form. Now we can go ahead and grab it. Alright. Alright. X, Y. Okay. Now again, let me use the red color here. Okay, for the first inequality. So over here you start with -1, right? Use rise over run, right? So going up 1, going to the right 1. So because this is 1 over 1 here, rise over run. So this is 1. Now we can get the line. Oh, not good. Not good. There you go. Alright, so this -1 is 1. So that's the first line, and it's solid line because it's an equal sign. And this is greater than equal, so we're gonna shade everything above the line. Okay, so I'm gonna go ahead and shade everything above this line. So it will be this. Alright, so this is above the line. You can use method 1, okay, which is picking up 1. But I get used to this, so I know that if it is greater than, so I know it's above the line. And this is mean above the line. Okay, it below, so we don't want it below. Alright, now let's do this one. So we're gonna start at 4. Let's use I think I'm gonna use the purple. I'm gonna start at 1, 2, 3, 4. So 4 right here. It's kind of hard to see, so I'm gonna use the green. So 4 right here. And you go you start here, you go down this is -1/1, and you go down 1, going to the right 1, go down 1, going to the right 1, go down 1, going to the right 1, go down 1, going to the right 1. So this could be 4, would be 4. 2, 3, 4. Right? It's going down 1, going to the right 1, right? Going down 1, going to the right, go down 1, going to the right, going down 1, going to the right. Yes, so it's right over here. Okay. Now I'm gonna connect them. Oh my God, it's I have to bend my body to draw this. So kind of go like this. Okay. Oh my God. Here you go. Oh my God, this one is beautiful. All right. So that's the green one, and we know this is less than equal. So this will be everything below the line. Everything below the line. So I'm going to shade it. Everything below the line. Below the line. Okay. So where will be the part we should take? Well, if we do intersection, which is n, then we're gonna shade everything overlapping each other, which is right over here, right? Which is right over here. This is where it's overlapping each other. But because this is all, so all mean we take everything. All mean we take everything, right? Let me see. I just want to make sure again I got everything correct. Okay. And all we take everything, it means what? It means whatever you shade, it doesn't matter it's blue color or red color, that could be the solution, right? Let me check one more time if it's good or not. It's negative x, so let's flip it, divide it, so x minus 1. Okay, this is good. And this is x plus 4, so we need negative x plus 4. Yep, so this is good too. And we set everything here, and we set this one greater than. I just want to make sure the red part over here I set it correct or not. So if I pick the 4, 4 x is 0, 4 greater than -1. Okay. Let's pick -1, -1. So -1 over here, -1 over here, -2. So -1 greater. So look like it's good. Yeah. So look like it's good. All right. Then what is the final answer here? What is the final answer here? So you're gonna check everything, right? Why don't I just feel that there's something not good? Let me check it one more time. I mean, the blue one is good, but the red one. Let me pick 0. See, look like 0 is not the correct one. It's not correct. Yeah, because you see that even though this is above the line, but even though this is above the line, let me see. Okay, I think something not good right here. Even though that is greater than is above the line, but the thing is that because we already changed the direction. You know, we already changed the direction. So if you think about it, if you put 0, if you pick a point 0, 0, right? You plug it in 0 minus 0, 0 greater than 1 doesn't work, right? Right? Pick a point right here 0, 0. 0 minus 0, 0 greater than 1 doesn't make sense. So the red part over here is not good. The red part is not good. Let me erase all the red part. Even though that it looks like it's good because we see that it's greater than, so it's above the line. But when we plug it in the point, it's not good. So it should be this one. Alright, it should be the other part. Oops. It should be this one. So I'm going to set it over here. There you go, like that. Alright. So the union, it means you take everything. Whatever you shed, you're gonna take it, right? Whatever you shed, you're gonna take. So it means everything over here. Everything over here. Everything over here. So let me use the yellow color to represent whatever what will be the final answer. So the final answer will be everything here. Okay, everything here except for this part right here. Okay, will be everything here. Alright, will be everything here. Alright, will be everything here too. Alright, there you go. There you go. There you go. Alright. Alright. So the solution will be everything except for the space right here. That will be the solution because we take everything, right? Alright. Now we go back to see something wrong again. So look like the method we apply. Let me go back to look like the method over here. You have to be careful, okay? So I'm gonna put over here, be careful, because it's not always true. So is you have to especially every time you divide by negative one, you flip the direction. If you don't divide by negative number and the direction will be the same as the original direction, then this is good. So but if you change if you divide by negative one, you multiply by negative one, and you change the direction, you have to be careful. So you got be careful with this method, okay? So I recommend that you should if you good, you can you go ahead use both method, okay? Because most of the time I use method number 2 here, but I always use method number 1 to pick a point and check like which part will be the solution. You see, in this case is the evidence that show you that it's greater than equal it's greater oh, I think I know why. I flipped the direction, right? Here you go. So it's look like it's good right now. Okay, so I think I have something wrong over here. This is greater than. Oh, okay. Alright. So it's greater than. Alright, so now I divide by negative number. Alright, so it's less than. Alright. It's less than, so it's under. Okay, so this is right. This is true. This is well, I'm gonna check whatever I just say. Okay, I'm gonna take it back. Okay, to ignore what I just said. So this is true. This is correct. I'm gonna go ahead and erase it. All right, this is true. So again, this is still true. Okay, it's working. All right, because I messed up with the sign down here. That's why the answer doesn't make sense. But I see why I messed up right now. I don't know why I changed the direction of the original question. Okay, so I'm gonna take it back whatever I just said. So this is still true if it's greater than, and above the line is less than, below the line it's greater than, on the right hand side if it's less than on the left hand side. Okay, good. Okay. I mean, I'm not gonna put this on the test, but on homework, you will see that. So make sure you understand. If you watch this again and you don't understand it, please let me know. Okay? It's not hard, but it's kind of a little bit confusing too if you not careful. All right. Again, I take back whatever I just said about. If you divide by negative and you flip the sign and the method 2 doesn't work, well, it's always work. Okay, it's always work. Because I mess up the sign right here. I mess up the sign right here. You know, sometimes when we do lecture online through the video, and we don't have face to face. So if the teacher have a careless mistake, then nobody remind me of that. If we do it in class, maybe some of you recognize this my careless mistake right here and see it. So I'm sorry for this, okay? But other than that, everything is perfect. Other than that, it's a very nice picture and a very nice graph. All right, so go ahead, watch this again, and let me know if you have any question. Watch it carefully, okay? Before doing home. I'll see you next time.